Space Force prepares for ground target tracking mission with upcoming GMTI satellite launch. Imagine a future where satellites high above the Earth track moving targets on the ground with precision and speed. This isn't science fiction. It's the ambitious vision of the U.S. Space Force, which is laying the groundwork for a revolutionary mission. But here's where it gets intriguing. While this capability could redefine how we monitor threats, it also raises questions about technology readiness and whether space-based systems can truly replace traditional aircraft. So, what does this mean for national security and defense innovation? Let's dive in. The Space Force is preparing to launch its first satellites designed for ground moving target indication, GMTI, within the next year. However, before these satellites are operational, the service is hard at work developing strategies and testing technologies that will form the backbone of this cutting-edge constellation. This effort involves close collaboration with intelligence agencies to create a framework that integrates data from space sensors, radars, and other sources into a unified system. The goal? To give operators real-time insights into ground-based threats, a job traditionally handled by aircraft like the now-retired E-8C Joint Surveillance Target Attack Radar System, JUSTARS. To enable this futuristic architecture, the Space Force has partnered with organizations such as the National Reconnaissance Office, NRO, and the National Geospatial Intelligence Agency, NGA. Together, they've deployed low-cost radar systems and electro-optical sensors as stepping stones toward building a robust GMTI infrastructure. According to Lieutenant General Deanna Burt, the operations chief of the Space Force, the next milestone is launching GMTI satellites into orbit in the coming months. Speaking at a virtual event hosted by the Mitchell Institute, she emphasized the importance of taking a methodical approach to ensure success. Burt described the process as crawl, walk, run, explaining that it involves training personnel, refining command and control architectures, and establishing machine-to-machine communication protocols. This careful preparation aims to ensure that when the satellites go live, everything functions seamlessly. It's no small feat, requiring coordination across global units and partnerships with entities like U.S. Space Command to develop comprehensive operational concepts. In fact, a new squadron is being established under Space Delta 7, the hub for operational intelligence, surveillance, and reconnaissance, ISR, to spearhead this initiative. This mission represents a significant shift in how the military tracks moving targets. For decades, aircraft have been the primary tool for this task, but aging fleets and technological advancements are pushing the Defense Department to look skyward. The fiscal 2026 budget request includes $1 billion earmarked for space-based GMTI, highlighting its importance. Yet, opinions may differ on whether satellites can fully replicate the nuanced capabilities of legacy platforms like JSTARS. And this is the part most people overlook. The Space Force isn't stopping at ground targets. Plans are already underway to extend this mission to tracking airborne moving targets, known as Air Moving Target Indication, AMTI. However, transitioning from air-based platforms like the E-3 Airborne Warning and Control System, AWACS, to satellites presents unique challenges. Unlike GMTI, the technology needed for AMTI isn't as advanced, meaning it could take several more years to mature. Complicating matters further, the Air Force recently decided to cancel plans to replace its aging E-3 fleet with the E-7 Wedgetail, leaving a potential gap in airborne surveillance capabilities. When asked about timelines for deploying an AMTI network, Burt remained tight-lipped but noted that lessons learned from GMTI development will guide the way forward. An ongoing study, set to conclude later this year, promises to shed light on the best technologies for tracking fast-moving aerial objects of varying sizes from space. Everything we're learning about GMTI will directly apply to AMTI, Burt explained during her remarks. She highlighted ongoing collaborations with commercial partners and industry experts to explore innovative approaches, including different sensor types and detection methods. These efforts underscore the complexity and ambition of the Space Force's mission. So, what do you think? Can satellites truly step into the shoes of aircraft for tracking both ground and air targets? Or does this pivot risk over-reliance on unproven technology? With billions of dollars and national security at stake, the debate is far from settled. Share your thoughts in the comments below. Do you believe the Space Force is headed in the right direction? U.S. Space Force launches first GMTI satellites, a new era in military surveillance. Imagine a world where the skies above us are not just a domain for commercial flights and weather satellites, but also a strategic battlefield for advanced surveillance. This vision is becoming a reality as the U.S. Space Force and its intelligence allies prepare to deploy their first ground-moving target indication GMTI satellites, a significant step forward in space-based reconnaissance. According to a senior service official, these satellites will soon begin launching, marking a new era in how we monitor and track moving targets from space. Vivian Mackey, the military space editor for Aviation Week based in Los Angeles, reported on this development on August 4, 2025. The U.S. Space Force has been conducting numerous exercises to determine the most effective way to transition the GMTI mission from ground-based systems to space. Lieutenant General John Thompson, a key figure in the Space Force, emphasized the importance of these exercises in ensuring that the new satellites can seamlessly integrate with existing defense systems. GMTI technology is designed to detect and track moving vehicles on the ground, providing critical information for military operations. Traditionally, this capability has been provided by aircraft and drones. But moving this function to space offers several advantages. For one, satellites can cover vast areas continuously without the need for refueling or pilot rest. They can also operate in regions where it might be too dangerous for manned or unmanned aircraft to fly. But here's where it gets controversial. Some experts argue that the deployment of GMTI satellites could escalate tensions between nations, as the ability to track movements in real time could be seen as a provocative act. What do you think? Is the deployment of these satellites a necessary step for national security, or does it pose a risk to international stability? For those interested in delving deeper into this topic, Vivian Mackey's full report is available in the Aerospace Daily Defense Report, a publication by the Aviation Week Intelligence Network, AWIN. A subscription to AWIN provides access to a wealth of market intelligence and data, keeping you informed about the latest developments in the aerospace and defense sectors. If you're already a member of AWIN or have a subscription to Aerospace Daily Defense Report through your company, you can log in with your existing email and password. Not a member yet? Discover how you can gain access to the essential insights and data you need to stay ahead in the rapidly evolving aerospace and defense community. Space-based radar, the future of aircraft tracking. Tracking aircraft using radar satellites instead of traditional surveillance jets remains a distant goal, despite ongoing efforts and investments. This is a crucial and evolving topic in military technology that promises transformative capabilities, but is still filled with significant challenges. But here's where it gets controversial. The Pentagon's plan to reduce reliance on airborne radar planes in favor of space-based sensors is meeting increasing resistance, raising questions about the feasibility and timing of this major shift. The U.S. Space Force is currently exploring how to develop and deploy satellite systems capable of continuously and dependably tracking airborne threats from orbit. This concept involves utilizing a distributed network of space-based sensors designed not only to monitor air targets, but also to keep an eye on moving objects on land and at sea. Such efforts are part of a larger strategic move as the Department of Defense contemplates canceling purchases of new E-7 wedge-tail radar aircraft, originally intended to replace aging Air Force platforms, in favor of expanding the Navy's fleet of E-2D Hawkeye planes. This shift has sparked strong congressional opposition, as lawmakers question whether enough is being done to maintain aerial situational awareness while pushing more surveillance responsibilities into space. Lieutenant General Deanna Burt, Deputy Chief of Space Operations for Operations, Cyber, and Nuclear, recently spoke at length about the current state and future plans regarding Space-Based Air Moving Target Indicator, AMTI, and Ground Moving Target Indicator, GMTI, capabilities during an online event hosted by the Aerospace Forces Association's Mitchell Institute. She emphasized that the Space Force expects to complete a thorough analysis of alternatives, AOA, this fall. This analysis will be critical in determining the feasibility, timelines, and technical approaches to deploying robust AMTI capabilities from orbit. Currently, the U.S. military relies mainly on an aging fleet of E-3 Sentry AWACS, Airborne Warning and Control System, aircraft for AMTI coverage, supplemented by a network of ground-based radars focusing largely on homeland defense rather than tactical battlefield operations. Notably, the Air Force has already retired its E-8 Joint Surveillance Target Attack Radar System, JSTARS planes, reflecting a gradual shift of certain radar functions from aircraft to space-based assets. As Burt explained, there isn't a single perfect solution or silver bullet technology for satellite tracking of moving targets in the air and on the ground. We expect that multiple detection methods or phenomenologies working in unison will be necessary to achieve reliable coverage. This acknowledgement highlights one of the significant technical hurdles. Different types of radar and sensing technologies need to be integrated to identify and track a range of targets varying in size, speed, and altitude. The $2.2 billion allocated by Congress to AMTI development as part of a recent reconciliation funding package focuses heavily on research, development, testing, and evaluation, RDTE, of these diverse technologies and how to combine them effectively within a satellite constellation. Burt also revealed that current testing explores how data collected by different sensor types can be processed automatically, using machine-to-machine communications, to classify targets and promptly relay targeting information to combat controllers or directly to aircraft cockpits. This automation is crucial given the time-sensitive nature of tracking fast-moving threats that could disappear within minutes. However, Burt stopped short of guaranteeing that operational space-based AMTI capability will be fielded within just a couple of years. Space Force leaders continue to look toward the 2030s as the target for achieving persistent, constellation-based AMTI and GMTI surveillance from orbit. An important part of present efforts concentrates on ground-moving target indicators, GMTI, with close collaboration between the Space Force, the National Reconnaissance Office, NRO, and the National Geospatial Intelligence Agency, NGA. The NRO, while officially part of the Department of Defense, works closely with the CIA and is America's primary satellite intelligence agency. The NGA specializes in geospatial intelligence, including the analysis of satellite imagery. Space Delta 7, the Space Force's Intelligence, Surveillance, and Reconnaissance (ISR) unit, based at Peterson Space Force Base, leads the GMTI mission. A small team of Delta 7 operators is embedded at the Joint Mission Management Center in Springfield, Virginia, collaborating alongside NGA analysts to develop and refine tactics, techniques, and procedures for space-based moving target detection. Beyond developing technical systems, the Space Force is actively coordinating with regional combatant commanders to figure out how to rapidly deliver space-based GMTI data to operational users in near real time. Artificial intelligence, AI, and machine learning will play an indispensable role, helping sift through vast sensor data streams, automate target recognition, and accelerate decision-making to engage fleeting threats in the field. Burt highlighted parallels between space-based GMTI development and advances made in space domain awareness, technology designed to monitor satellites and other objects in orbit. The use of AI there to detect unusual satellite behavior and quickly flag potential anomalies serves as a model for the automation needed in moving target identification on Earth from space. The satellite infrastructure for GMTI is already under construction, with initial launches of electro-optical sensors and low-end radar satellites paving the way, followed by those equipped with more capable radar payloads for GMTI. Additionally, the Space Force has launched a significant number of communications mesh network satellites that facilitate rapid data transfer among constellation members. However, details about the exact number and capabilities of GMTI satellites remain classified. Burt observed that the technological lessons learned in GMTI development will inform and pave the way for future AMTI systems focused on airborne targets. Because of differences in target types, some being larger, some smaller, some faster, the best combination of sensor phenomenologies will vary, and space-based detection faces unique challenges distinct from those encountered by aircraft or ground-based sensors closer to the targets. Despite the promising potential of space-based GMTI and AMTI sensor networks to revolutionize surveillance with advantages in persistence, global coverage, and survivability compared to traditional airborne and ground radar platforms, the path forward is fraught with complexity. The threat environment in space is becoming increasingly hostile, and the military is investing heavily in distributed constellations of smaller satellites to build resilience against potential losses and improve coverage. Notably, Space Force leaders have emphasized that even as space-based capabilities mature, airborne and ground assets will continue to play essential roles for some time. Space-derived tracking often lacks the resolution achievable from platforms situated closer to the target. General Michael Getline, former Vice Chief of Space Operations, highlighted that orbiting sensors face inherent resolution limitations, making a complete transition away from airborne early warning platforms unrealistic in the near term. This reality fuels ongoing debates around the Air Force's efforts to modernize its airborne radar fleet. The initial plan to replace portions of the aging E-3 Sentry aircraft with newer E-7 Wedgetails is now under threat, as the Pentagon announced its intention to cancel the E-7 program, opting to procure more Navy E-2D Hawkeyes instead.